Okay, Mercedes, you want to get that on recording?
What?
What do you hate? You say it? Ooh. Ooh. She said she hated me earlier. Yeah, she did. She said she hates me. No, no, no. We'll just give 2 tests on Wednesday. 1 for the class, 1 for Mercedes. All right, here we go. What? Oh. Good times. I didn't know that. Carthage. Fundamental theorem of algebra. Today's a big day, folks. Now, I want you to know for fundamental theorem of algebra, this is not the exact fundamental theorem. This is kind of a synopsis of a few theorems put together, but this is the main idea, and it's really good stuff. One thing that the fundamental theorem of algebra says, every polynomial of degree n has exactly n solutions. So, for example, p of x is equal to 4x to the third minus 2x plus 1 has how many solutions? 3. That's one thing it says. Another thing it says is this. Every polynomial, given it as a coefficient of a and solutions of c sub 1, c sub 2, c sub 3, and so on, can be written in a very specific form. What form is that? Well, I'll show you. If 2 is a solution, then what's a factor? X minus 2. Very good. So you could just write x minus the solution, and that's a factor, correct? So every polynomial can be written like this. P of x is equal to some coefficient times x minus one of the solutions times x minus another solution times x minus another solution times x minus the last solution. You could just simply write as x minus the solutions in factored form. If polynomial p of x has a solution a plus bi, then another solution must be, anybody guess? A minus bi. Because it's the conjugate. So one last piece we want to note here is that imaginary solutions come in pairs. Why? Why do imaginary solutions come in pairs? You're already here. Not impressive if you've already been in class. Yes. Okay, good try. I don't know. IDK works. Yes. Why? Yes. Very good. Look at this. 2 plus or minus the square root of negative 4 over 3. Let's say you get that. What's the square root of negative 4? 2i. So when you do that, you get 2 different solutions, correct? Imaginary solutions come from square roots, and you end up with a positive and a negative. Also, think about this, okay? If you have a cubic, is it possible to draw a cubic where it does not cross the x-axis? So therefore, 1 must be real, which reduces it down to 2 more solutions. And in this case, they would both be imaginary. Look at this one. Is it possible to draw a quartic such that it does not cross the x-axis? Yes. So you could have, pairs of 2, okay? So you could have 2 sets of 2 imaginary solutions in a situation like that. So they come in pairs, all right? They always come in pairs. So this is where we put it all together. Lots of notes today. No assignment. Your assignment is going to be to finish your study guide, and you have a full work day tomorrow. Thank you, Mr. Gens. What a nice person, Mr. Gens. Thank you.
Thank you, Mr. Dad.
Whoa. All right. Okay, here we go. Example 1. For the following, identify total possible number of roots. So, on your study guide, these are some of the problems that you weren't able to do yet. How many possible number of roots are there? 4. Very good. Then it says possible number of real and imaginary. If there are 4 possible roots, how many of them could be real? 4. Suppose there were 4 real roots. How many imaginary ones would there be? 0. Suppose there were imaginary roots. How many would there be? There could be, say, 2. If there were 2 imaginary, then how many real ones would there be? Suppose there weren't 2. Suppose there weren't 0 imaginary, then there would have to be 4. If there were 4 imaginary, how many real ones would there be? See how these add up to 4? You're either going to have 4 and 0, 2 and 2, or 0 and 4. We don't know which situation it is yet, but we're going to be able to figure that out very quickly here. And we do it in letter C and D. C says the possible number of positive and negative real roots. Positive real and negative real. How do you determine the number of possible positive real solutions? Number of sign changes. How many sign changes are there? 1. Let's now look at the number of negative sign changes for negative reals. So P of negative x is x to the 4th minus 16. It's the same thing, right? The odd powers stay the same. The even powers stay the same. The odd powers change. There's no odd powers here. So negative real. How many sign changes? 1. So I have 1 positive, 1 negative. Look at that. Positive, negative. That's a sign change. Okay. Now, look at this. Okay. So, how many real solutions am I going to have? 2. I have 2 real solutions. So, how many imaginary ones are you going to have? So, already from the beginning, we could diagnose exactly what's going to happen here. We know we're going to have 2 real, 2 imaginary. Of the real, 1's positive, 1's negative. So, we could tell a lot about the problem before we even begin. D. What are the possible rational root choices? What are my P's? What are my Q's? So my possible choices are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. E, we want to find them. So I go to my my decision tree. Does this factor? Yes. So do you have to use rational root theorem if it factors? No. So we factor it. How does it factor? X squared plus 4, x squared minus 4. Very good. Does this factor? No, it does not. Very good. So Colton says it doesn't factor in a way that we're used to, but what we learned through the fundamental theorem of algebra is everything technically does factor. Okay? So we'll do that in a second. What do you see as your solutions? Look at that. 1 negative, 1 positive. It confirms our answer for us. X squared plus 4. It doesn't factor in a way that we're used to, so you can either use a quadratic formula or you could go ahead and solve for it algebraically. Subtract your 4. X squared equals negative 4. What is the square root of negative 4? Plus or minus, because there's 2 solutions, 2i. So for letter E, you list your solutions. Plus or minus 2. Plus or minus 2i. Do you see this? How this confirms what we originally set up? There's a positive, there's a negative, and there's 2 imaginary. Is that awesome? So this isn't that old. This is like 300 years old, the mathematics. Okay? Gauss, Descartes, they came forth and they put these ideas. And to them, they were pretty simple. You should see the extensions of these as they move forward in mathematics. Very difficult to understand. The last thing we want to do is F. We want to list the factorization of this polynomial. Namely, P of X can be written as, I'll do the first one, see if you guys can finish it off, X minus 2 times X minus negative 2 or X plus 2 times write it with all single degree powers. X minus 2i and X minus negative 2i or X plus 2i. That is the factorization in linear form. That is so important. You won't use it again until you take a calculus 2 or an abstract algebra course in the future. But this really has helped change and shape mathematics. It's awesome. Okay. That was an easy problem. Ready for a difficult one? All right, flip it over. Colton, should we be calling the hospital? Is it Ebola? Mumps. Okay. Hockey people these days are getting mumps. Yeah, you've heard about the North Stars. The Wild have what? They've had 6 people on the team get the mumps, something like that. So, well, it's just, I mean, obviously, within the team, the Minnesota Wild, they spend a lot of time together, and so, no. Yeah, he should be. Well, he could help out their power play right now. It's pretty bad. So, anyway, all right. Here we go. A, how many possible roots? 3. B, I look at real and imaginary. How many real solutions could it have? 3. If it had 3 real, how many imaginary would it have? 0. If it did have some imaginary solutions, how many would it have? They come in pairs. Real. So if there are 3 total solutions, these would be real or imaginary, okay? Then 3 of them would be real or 0 would be imaginary. The number of imaginary is always an even number. If there were 2 imaginary, how many real would there be? And you guys, we all agreed that a cubic is for sure going to have 1 for sure, right? You can't draw it without crossing the x-axis, so it's got to have 1 real solution. Okay, so now C, we look at positive real and negative real. I look at the sign changes. How many sign changes? 0. P of negative x. Very good, Miss Mercedes. Negative 8, x to the third plus 1 is what P of negative x is, and there is exactly 1 sign change. So, what situation do we have going on here? 1 real, 2 imaginary. You can see how that works out perfect. 1 real right there, and it happens to be negative. The other 2 would have to be imaginary. Let's confirm that by doing our work. First, let's look at the choices you would have. We have 1 and 1. What are factors of 8? So our choices would be plus or minus 1, plus or minus a half, plus or minus a fourth, and plus or minus an eighth. Good? E, we find them. Does it factor? Sam, how does it factor? Very good. Sam sees that here you have the sum of 2 cubes. Rather, a cubed plus b cubed factors to a plus b times a squared minus ab plus b squared. Now, I gave you that factorization on a sheet of notes at the beginning of this unit. You have it in your packet. If we factor this, Sam already identified that in this case, A is going to be 2x. What is B? 1. What's A squared? 4x squared minus 2x plus 1. I can already see one of the solutions. What is it? Negative a half. Look, that's my negative real. We've already identified it. We have something to confirm our answer. 4x squared minus 2x plus 1. Does it factor? No, so I have to use the quadratic formula. No groaning when you hear the quadratic formula. It's this long. Remember, the cubic formula is a page and a half. And the quartic is 4 pages. Yes. Right there. That means there's a sign change. We're not factoring that. We're factoring this. I only use p of negative x to identify the number of negative real solutions. That's it. Okay? Is that clear? Okay, quadratic formula. You guys are so good at this, you could set it up quick. Negative b plus or minus square root of 4 minus 4 times 1 all over 8. Remember, that used to be so complicated you could only do like 6 problems in a day in an algebra class. Now, boom, crank it out. What's 4 minus 4 times 1? So I got negative 12, 2 plus or minus the square root of negative 12 over 8. What's the perfect square you can take out negative 12? Instead of taking out 4, take out negative 4. Okay? So 2 plus or minus negative 4 times 3. Okay? What is the square root of negative 4? 2i. So you have 2 plus or minus 2i roots of 3 all over 8. What are they all divisible by? 2. So you have, I'm going to write as 1 over 4 plus or minus root of 3 over 4 times I. Because that's how we were writing it on Friday, I'm going to write it like that now. Okay with that? No. But that's because I think you're a nice kid. All right. So my solutions. Negative 1/2. All right. I got negative 1/2. I also have 1/4 plus the root of 3 over 4 times I. And I have 1/4 minus the root of 3 over 4 times I. Yes, you could write plus or minus and not write them both out. That's fine. I just did that to help out my next example here. And that is writing the full factorization in F. P of x would then be equal to, nope, you don't need to. I'm just doing it to try to tie everything else in because the next examples we do, we will actually use the factorization to build up. So, x, what? Plus 1/2 times x minus the quantity 1/4 plus the root of 3 over 4i times x minus the quantity 1/4 minus the root of 3 over 4 times I. I used a double set of parentheses to isolate that binomial. I did get a comment from somebody in a different hour that said, I would rather not, I didn't want to use this double set of parentheses. Well, if you don't put the parentheses, you better distribute your negative through. Otherwise, it's wrong. It doesn't matter. I've had the question numerous times. You got to do that. That's just solid mathematics. Okay, one more, then we move to easier problems. Okay, all right. Number of solutions. 3. Real or imaginary? Real would be 3, imaginary 0. If there were imaginary, how many would there be? 2, and then how many real would there be? 1. Some people have confused positive and negative real with real and imaginary. I want to be clear here. Letter C, what I write down for letter C, does that have anything to do with imaginary numbers? Nothing. Does it have something to do with the real numbers? Everything. Okay? So, how many positive real, how many sign changes are there right now? There are 3 sign changes. Or it decreases by a factor of 2 to account for the imaginary, 3 or 1, very good. Negative real, I need to look at p of negative x. Very good. Negative 2x to the third, minus 13x squared, minus 26x, minus 10. There are exactly 0 negative real choices here. D, choices for the rational roots theorem. Factors of 10, 1, 2, 5, and 10. Factors of 2. List them off, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Now let's do the fractions. 1 over 1. Oh, I'm sorry. 1 over 2. A half. 2 over 2. Already got it. 5 over 2. 10 over 2. Already got it. Does it factor? It does not factor. We use the rational roots theorem. Now, everybody pause here because I'm going to show you something that's going to save you time. Well, it should, because this is the way I did it. This is one of those times where it's like, it's worth listening here, okay, to help you on the test. I don't want to plug in certain numbers. What numbers do I not want to plug in? Negatives, why? There are no negative real solutions. Be smart about your choices. Second of all, do you guys mind trying to plug in the number 1? I don't, but does 1 work? Try it. Doesn't work. There, did it. A lot of times it's easy to see if 1 works out, but it's tougher with other numbers, right? Especially fractions. So remember, you don't get a calculator on this test. So how can you work through this efficiently and effectively? Here's what you do. I'm going to guess 2. So I don't plug it in. Just because. No, 2 doesn't work. 2 doesn't work. I'm going to guess 2, okay? And instead of trying to plug it in and do all this multiplication, I'm going to simply just divide it. If it works, what should I get? 0, let's try it. 2, 4, negative 9, negative 18, 8, 16, 6. I don't think you can plug it in that quickly in your head. I think synthetic division is the fastest way to go through and check. Did it work? No, 2 didn't work. We shouldn't try negative 1. We shouldn't try negative 2. So you can either bump up to 5 and 10, or you can try the fractions. I know fractions really give you anxiety, but when you're using the synthetic division, it's really not that big of a deal. So let's try 1/2. We know there's got to be 1 positive for sure, if not 3. So we drop the 2. Worked. And now I don't even have to go back through and divide it because it's already done. So instead of plugging it in, go ahead and use synthetic division to your advantage. Do you see that? Does that make sense? I saved time. I was efficient and effective. So I have x minus a half times 2x squared minus 12x minus 20. Does that factor? Take out a 2. Does that factor? No, it doesn't. Whoops, sorry. Thank you. That doesn't factor, so I have to use the quadratic formula. Negative b, yes. 6 plus or minus the square root of 36 minus 4 times a times c, all over 2a. What do you get in the discriminant? 36 minus 40. 6 plus or minus the root of negative 4 over dose. What's square root of negative 4? 2i. So I get 6 plus or minus 2i over 2. Are both those divisible by 2? So divide it, and you get 3 plus or minus I. So our solutions are 1/2, 3 plus I, 3 minus I. Therefore, the factorization for p of x is equal to x minus a half times x minus the quantity 3 plus I times x plus, x minus, it's always x minus, the quantity 3 minus I. Technically, we factored a 2 out, so you should put a 2 back in here, but it's really not that important for the problem. See that? Like it? Haley, you're supposed to say yes. I love it and I embrace it to its. I appreciate how beautiful it is in its place in mathematics for us. All right, get it. All right, we'll try an easy problem for you, okay? Write an equation for a polynomial with degree 3. Now what we're going to do is we're going to take the solutions, and we're going to use those solutions to write an equation for a polynomial. So it has degree 3. So if it has degree 3, how many solutions does that? 3. I know one of them's 4. I know another one is I. What would the other one be? Negative I. Why? And the other one is always the conjugate. Very good. Tyler answer A for the. In fact, you just get an A on test. You don't even need to take it. Okay. Yep. However, if you don't run a 159 this year in the 800, I give you an F. Okay. Whoa. 159 is big time. All right. Oh, all right. Colton's running the 800 this year. Yeah. All right. Boom. Can't wait. I'm calling cappers. All right. All right, p of x is then equal to x minus 4 times what? X minus I times x plus I. So we're going to multiply this out to come up with a polynomial. First, I'm going to focus on those two binomials because the I should go away. P of x is equal to x minus 4 times x times x. X times I and x times negative I will go away. Negative I times I. What is negative I squared? Positive 1. Does it make sense that x squared plus 1 has solutions of plus and minus I? Whereas x squared minus 1 would not have those solutions. X squared minus 1 would have solutions of plus and minus 1. So you should be thinking about that. Okay, now we finish it off. X times x, x to the third. x squared times negative 4. Negative 4x squared. X times 1 is x. And negative 4 times 1 is negative 4. Got it? Well said. Yes, that is the answer. So easy, well said. Let's try a more difficult one and end our unit. We end our unit with example 5. Write an equation for polynomial with degree 3. Sorry, I forgot to put that in there. With solutions of negative 3 and 4 minus 2i roots of 3. If it has 3 solutions, it should have a third one listed up here. What is the other solution? So therefore, my polynomial will be x plus 3 times x minus the quantity 4 plus 2i roots of 3 and x minus the quantity 4 minus 2i roots of 3. See some of my close friends in here kind of dozing a little bit. It's a tough 7th hour during the day. You know what the best thing to do if you get a little tired is? Yeah, sit up, because that allows your lungs to take in more oxygen, which will keep your brain more focused. Yep. No, Tyler's on. He's ready to go today. He's like, bring it on. It's my good friend Dom here. It was amazing. The eyes were closed, but the pencil was. And then he came too. It's all right. I've been there. It's tough. It's tough. He's probably working hard doing math at night and stuff like that. So I got it. All right, let's finish this off, okay? Now, there's a number of different ways to teach this. I'm going to try to teach you the way in which people make the least number of mistakes. What I encourage you to do is to first just distribute that negative. X minus 4 minus 2i roots of 3. And then x minus 4 plus 2i roots of 3. Everybody okay with that? So now I'm going to focus on these second two right here. And when I multiply those out, I'm just going to do that right now. I've got a trinomial. How many terms will that give me? 9. X times x. X times negative 4. X times 2i roots of 3. 2xi roots of 3. Never written that before, have you? Damn, it's fun. First times for some things. All right, we move on. Negative 4 times x, negative 4x. Negative 4 times negative 4, 16. And negative 4 times positive 2i roots of 3, negative 8i roots of 3. Now we move on to our last term. Negative 2i roots of 3 times x would be negative 2xi roots of 3. Negative 2i roots of 3 times negative 4, positive 8i roots of 3. And now I got one more. Negative 2i roots of 3 times 2i roots of 3. Got to be careful with this one. Negative 2 times positive 2. Negative 4. I times I. Negative 1. And root of 3 times root of 3. 3. What's negative 4 times negative 1 times 3? Positive 12. Okay. Sweet. Yeah, exactly. A lot of them should cancel. P of x is equal to the quantity x plus 3 times, I got an x squared. Does anything combine with that x squared? Let's cancel stuff first. How about that? What cancels up here? All the i's should cancel. 2xi roots of 3 and negative 2xi roots of 3. Negative 8i roots of 3 and positive 8i roots of 3. So it looks like I got my x squared. Can I combine any x's? Minus 8x plus 28. All right, we sorted that out. Almost done, aren't we? P of x, x to the third, minus 8x squared plus 28x. Move on to our 3. 3x squared minus 24x plus 28 times 3, 84. What terms can we combine? Negative 5x squared, 28x and negative 24 is positive 4x. This is the polynomial that has solutions of negative 3 and 4 minus 2i roots of 3. You guys know my good friend Karina? Oh, wow. Yeah. Should we just send her to the principal's office? Okay. All right, folks. So your assignment's finished. The study guide. I'm going to stop this. Everybody take out your study guide. Take out your study guide.